Hey everybody, we are back to work on the example problems in the notes for section 9.3. So if you remember from 8.2 to 8.4, everything that we did before the second exam, uh, we talked about normal random variables and the z transformation, and we were finding the probability that, a value is greater than or less than or maybe in between two numbers in some interval. And we're going to be doing the same exact thing. We're just now going to be applying this to the sampling distribution of the sample mean. So the original formula we were working with was z equals x minus mu divided by sigma. So we're basically going to be working with this same formula, but like I said, we need to apply it to the sampling distributions. So if you look over here, that's what we have done. And let me explain all this. So remember, x bar, that's your sample mean. That's the mean of one particular sample. And it'll be a randomly chosen sample. And mu of x bar, that's the mean of the sample means. Sigma of x down here, that's the standard deviation. You know what, I'm sorry, that should be x bar. I'll make sure that is fixed on the notes, but that's sigma of x bar, and that's the standard deviation of the sample mean. Now you'll notice that we have another equal sign, and this is actually the formula we are going to work with. So I'll explain this part. Well, we still have x bar. That hasn't changed. But notice this mu, it went from mu of x bar, the mean of the sample means, to just mu. So remember that central limit theorem, CLT, part of it stated that the mean of the sample means, so mu of x bar, is equal to the population mean. So that's all they did, is they made a simple substitution. The mean of the sample means is equal to the population mean. So we're going to actually be using population mean in this formula. And then below, another formula I gave in the last video is the standard deviation of x bar can be calculated by the standard deviation of the population divided by the square root of the sample size. So this is the standard deviation of the population, and then n is always sample size. So this is what we're going to be working with. We're going to have a sample mean, we're going to have a population mean, a population standard deviation, and a sample size. And we'll plug and chug. Okay, so let's get started with problem 1. The quality control manager at a computer manufacturing company believes that the mean life of a computer is 120 months. So I'm going to start writing down the information. They say, let's highlight this, mean life of a computer is 120 months. That's my mean, so I'm going to put mu is equal to 120. With a standard deviation of 10 months. So more information. They're giving us the standard deviation. Now, they're not being very specific. They're just saying mean. They're just saying standard deviation. That is referring to the population mean and the population standard deviation. So that's why I just have regular old mu equals 120. Regular old sigma is equal to 10. Okay. If he is correct, what is the probability that the mean of a sample of 90 computers would be less than 117.13 months. So another thing to highlight, they're telling us the sample size, a sample of 90 computers. So that's our N. N is going to be equal to 90. And these are the three main pieces that you'll be picking out of every problem. Now, what are they asking? What do we need to find the probability of? So what is the probability that the mean of the sample would be less than 117.13 months? So to write this in the notation we've been using, the probability that the sample mean, the mean of the sample, x bar, would be less than 117.13, right? That's exactly what they're asking. The probability that the sample mean is less than 117.13. Well, just like the last problems, we need to standardize so that we can use the standard normal distribution, because everything just works a little bit easier with the standard normal distribution. So we're going to convert things to z. Before we do that, I'm going to give myself a little extra room on this problem. Okay. So that's where this formula up here comes in. So maybe, I'm not going to do too many colors. So z is equal to, I'm just going to write it out, x bar minus mu all over sigma divided by the square root of n. The more you write it out, the easier it'll be to remember. Okay, so now we got to figure out what's what. Here I can use colors. X bar, that's coming from what the probability, like what we're asking, this probability statement. So that is going to be the x bar. So we got 117.13. And then the rest, we just plug in from the information we already pulled out. Minus mu, which is 120. All of that is divided by sigma, which is then 10. And that's divided by the square root of the sample size, which is 90. Okay. So just got to calculate this out. Real quick, I actually want to show you guys something. And I have my email open, sorry about that. And as you can see, I've already done some stuff here. Let me just start this over. So, since you guys are going to be at home, and if you have like a tiny calculator that doesn't do well with like all these parentheses and stuff, this might be helpful. This is, I'm using Desmos. You can see the link up here. You can literally just Google search Desmos scientific calculator and the link will pop up, or you can type in this link, desmos.com/scientific. So the reason I like to do this is we can just like type everything in here and see everything as a whole. So here's what I mean. So now type in the problem. We had 117.13 minus 120. And all of that, so I'm going to have to highlight that, is being divided by, so real quick note, on that, I highlighted it and I hit my divide on my computer, but you can also just highlight it and then hit divide. And then I'm going to type in the bottom, 10 divided by, and they got symbols down here, square root of 90. So look, you can double check that everything's typed in correctly and the answer shows up on this side. So we have a really long decimal. We are going to be using a z-table. And remember, z-tables, they only go 2 decimal places, to the tenths and the hundredths spot. So we're going to round to the hundredths. So since there's a 2 in the thousandths spot, we're going to leave the number in front a 2. So our answer is going to be negative 2.72. So negative 2.72, whoops, Meant to draw that better, but actually, I don't know why I was underlining it. We don't need to because we calculated it out. That's the answer for z. That's not the final answer. But our z is equal to negative 2.72. So I'm going to erase this stuff on the side just so I have a little bit more room to write. Hopefully you copied that down. You can always just go back to the beginning of the video and re-watch, right? Okay. So now I'm going to rewrite this. Oops. Equals. So we converted our sample mean here to a z-score. So we're going to find the probability that z is less than negative 2.72. All right, and this is where the z-table comes in. So hopefully you remember, you guys just had an exam on this. Z-tables are from the left. Right? They give you the area, I shouldn't say from, they give you the area to the left. And that's all they give you, is the area to the left. So, that's good news, because that's exactly what we want right here. And I can prove that if you don't believe me. Let's just draw a quick picture. So, here's our curve. Negative 2.72 is going to be somewhere over here. So I'm going to divide our curve up at that number. We'll say this is negative 2.72. And we want to know the probability that z is less than that. Less than a number, we're going to shade to the left. So this is what we're trying to find, this area, which is what the z-table gives us. So I'm going to pop over to my z-table. It's a negative number, so make sure you're in the negative z-table and look for negative 2.7 and then the 2. We land at 0.0033. Make this smaller. Equals 0.0033. And that, my friends, is the answer. Because once again, if we're finding less than a number, that means the area to the left, and that's all you got. You literally just got to look that up. If it's to the right, or there's other versions of this problem that we're going to look at, there's a little more work involved. So just to kind of reiterate how you want to do these problems. Start by picking out your information. You're going to be given a population mean, population standard deviation, perhaps a variance. We'll have a similar problem that we'll discuss what happens in that case, and then sample size. And then they're going to ask you to find a probability. You want to kind of write that out, and then plug all your information into this Z formula that fits with the sampling distribution for the sample mean. And then, yeah, calculate it, and once that gives you your z-score, you want to rewrite your probability statement in terms of z, and then look it up. Or sometimes there might be a little bit extra work, but figure out that area. Okay, so that was just the first problem, and I'm sure I'm approaching maybe 10 minutes. So I'm going to do another video with more examples. I will see you then.